In section 6.4, we're looking at linear inequalities in one variable. So we will study how to solve linear inequalities. A linear inequality is defined as ax plus b is less than or equal to c, where the inequality symbol can be less than, greater than, less than or equal to, or greater than or equal to. Solving an inequality is the process of finding the set of numbers that makes the inequality a true statement. These numbers are called the solutions of the inequality, and we say that they satisfy the inequality. The set of all solutions is called the solution set of the inequality. The table shows how to represent various subsets of real numbers on a number line. Open dots indicate that the number is not included in a set, and closed dots indicate that a number is included in a set. So we're going to let A and B be real numbers such that A is less than B. So we have set builder notation on the left and then the graphs on the right. The first one says the set of all x such that x is less than A. And so what's a helpful reminder on these is that the direction of the arrow tells you which way you're going to shade. So since my arrow is pointing to the left, I want to shade to the left. And since it was strictly less than, I'm going to have an open circle on A. For the next one, we have the set of all x such that x is less than or equal to A. So again, we're going to shade to the left, but this time we have a closed circle on A. For the third one, we have the set of all x such that x is greater than b. So this time, the arrow is pointing to the right. So we want to shade to the right of b. Since this is greater than b, then we're going to have an open circle and shade to the right. For the next one, we have the set of all x such that x is greater than or equal to b. So again, we're going to shade to the right, but this time we have that closed circle on B. And now let's start to combine these together. For the last four, we're going to use both A and B. So the first one, the set of all x such that A is less than x and x is less than B. So as you can see, our variable is in between our A and B, which is telling me where I'm going to need to shade. In between these two, they're kind of like boundaries. And so because they're both strictly less than, then we're going to have open circles on both A and B, and then we shade in between. You could think of this as two separate. This says that x is greater than A, and it also says that x is less than B. All I did was split the compound inequality into two separate. The rest of them are in the same format, it just changes the sign. So the set of all x such that A is less than or equal to x and less than or equal to B means that we have closed circles on A and B, and then we shade in between. For A is less than x, which is A is less than or equal to x, which is less than B, means I'm going to have a closed dot on A, but an open circle on B. And for the last one, A is less than x or less than or equal to B. Now A has that open circle and B has a closed circle. So let's go ahead and graph some sets on our own. So we have x such that x is less than 3. So are we going to have an open dot or a closed dot on 3? We are going to have an open dot. And am I going to shade to the left or to the right? Since our arrow is pointing to the left, we are going to shade to the left. So we're going to come over to 3, and we're going to put an open circle. And then we are going to shade to the left. Let's try another one. The set of all x such that x is greater than or equal to -1. Are we going to have a closed dot or an open dot on -1? Because it's greater than or equal to, this is going to have a closed dot. And am I going to shade to the left or to the right? Because my arrow is pointing to the right, we're going to shade to the right. So we have a closed dot on -1, and we are going to shade to the right. Let's go ahead and try one more. We have the set of all x such that -1 is less than x, or x is less than or equal to 3. So we have two different boundary points we need to look at. So at -1, am I going to have a closed dot or an open dot? Because it's strictly less than, we're going to have an open dot on -1. And at 3, we're going to have a closed dot because it's less than or equal to. Because our x is in between our two boundaries, we're going to shade in between. So go to -1, we have our open circle, and go to 3. Where we're going to have our closed circle, and then we are going to shade in between. The procedure for solving linear inequalities is the same as the procedure for solving linear equations, with one important exception. When multiplying or dividing both sides of the inequality by a negative number, we need to reverse the direction of the inequality symbol, changing the sense of the inequality. So if you multiply or divide by a negative number, the sign is going to flip. Other than that, solving them is the exact same process that we have already been doing in this section. So let's solve and graph the solution set for 4x minus 7 is greater than or equal to 5. So just like we would solve a linear equation, the first thing we want to do is add or subtract to try and get x by itself. So we can undo the minus 7 by adding 7 to both sides. And so this ends up canceling on the left. And we get that 4x is greater than or equal to 12. And to undo that multiplication, we're just going to divide both sides by 4. Now, because this is a positive 4 we're dividing by, we don't need to worry about switching the signs. We can leave it just as it is. And so what we end up getting is x is greater than or equal to 3. To write this in set builder notation is pretty easy. all we have to do is put a vertical bar in front of what we just found. We're going to put the variable, which is x, and then we put our little curly braces around it. Now that we have found the answer, are we going to have a closed dot or an open dot on 3? We're going to have a closed dot. And are we going to shade to the left or to the right? We're going to shade to the right because that's the way that the arrow points. So let's come back up here. We're going to have that closed dot on 3. And then we are going to shade to the right. Let's go ahead and try another one. We have 1/3 x is less than 5. So we'd want to get rid of the fractions by multiplying by the LCD. And the LCD in this case is easy because we only have one denominator, and that's 3. So we're going to multiply both sides by 3 so that we can get rid of that denominator. And because we're multiplying by a positive 3, again, we don't have to worry about flipping the sign. On the left-hand side, the 3's are going to cancel, and we're just left with 1x, or just x, is less than 15. So again, we go ahead and put that vertical bar in front of whatever we found, and then the variable, and we put our curly braces around it. At 15, we're going to have an open dot. And we're going to shade to the left. So let's go ahead and number our number line here. A little crowded, but we make it work. We have an open dot on 15. And then we are going to shade to the left. Let's go ahead and try another one. We have negative 3x is less than 21. So to undo the multiplication, we're going to divide by negative 3. Now because I'm dividing by a negative 3, the sign needs to flip. So it's not going to be less than anymore. It's going to say x is greater than negative 7. We put our vertical bar up front with our variables, and then we go ahead and put our curly braces around the whole thing. And we're going to go ahead and number our number line. We're going to have, it's going to be an open circle or an open dot at negative 7, and we're going to shade to the right. Let's go ahead and try something a little bit more complicated. So we have 6x minus 12 is greater than 8x plus 2. We're going to solve this the exact same way that we have been. So we want to get x's together and then the constants on the other side. So I'm going to go ahead and add 12 to both sides. And so those are going to cancel on the left. And we have 6x is greater than 8x plus 14. We need to get the x's to the left-hand side, so I'm going to subtract 8x from both sides. And so they're going to cancel on the right. And we have negative 2x is greater than 14. And so to undo our multiplication, we're going to divide both sides by negative 2. And so what we end up with is now x is less than negative 7, because we have to flip the sign from the negative. We put the vertical bar in front with our variable, and then we just encase it in our curly braces. And so that means we're going to have an open dot at negative 7. And then we are going to shade to the left. So I'm just going to use the same numbers from the number line above. And so we go down to negative 7, and we put our open circle. And this time we're shading to the left. Let's go ahead and try another one. We have 2 times x minus 3 plus 5x is less than or equal to 8 times x minus 1. So the first thing we need to do is we need to distribute so we can get rid of the parentheses. And we're going to do that on the left and the right-hand side. So we have 2 times x, and we have 2 times negative 3, plus 5x is less than or equal to, we have 8 times x, and then we have 8 times negative 1. So let's go ahead and multiply and simplify. On the left, we have 2x minus 6 plus 5x is less than or equal to 8x minus 8. Well, on the left-hand side, we have some like terms. We have 5x and 2x, which gives me 7x minus 6 is less than or equal to 8x minus 8. And so now that we've broken it down and simplified, we can try to get our x's to one side and our constants to the other. So I'm going to go ahead and add 6 to both sides. And so it cancels on the left. We have 7x is less than or equal to 8x minus 2. And now we need to get our x's to one side, so I'm going to subtract 8x from both sides. And so it cancels on the right, and we end up with negative x is less than or equal to negative 2. But remember that negative x is like having negative 1x. And so we want to have just x, which means we're going to divide both sides by negative 1. But because I'm dividing by a negative, that means that my sign is going to have to flip. And so we end up with x is greater than or equal to positive 2. And so we're going to have a closed dot on 2. And you are going to shade to the right. In our next example, the inequality has 3 parts. By performing the same operation on all 3 parts of the inequality, our goal is to isolate x in the middle. So it works just like the other ones, except we want to do the same thing to all 3 parts, and we want to get x by itself in the middle. Instead of splitting it into 2 separate inequalities and solving, this is a lot quicker and more efficient. So let's go ahead and take a look. We have negative 3 is less than 2x plus 1, which is less than or equal to 3. So looking at just the middle, we have 2x plus 1. The goal is to get x by itself. So again, we always do addition and subtraction first. And so I'm going to subtract 1 from the middle. And so that means I'm going to subtract 1 from the other 2 pieces of our compound inequality. So in the middle it cancels, which is what we want. So negative 3 minus 1 gives me negative 4 is less than 2x, which is less than or equal to 3 minus 1, which is 2. Again, looking at the middle, we want to undo the multiplication so we can get x by itself, which means I'm going to divide by 2, but that means I need to divide by 2 on the outside portions as well. And so in the middle, it ends up canceling, and we're going to get x by itself, which is the goal. We have negative 4 divided by 2, which is negative 2, is less than x, which is less than or equal to 2 over 2, which is 1. And so to write this again, we put that bar up front, we put our variable, and then we put our curly braces. And so at negative 2, we're going to have an open dot. And at 1, we'll have a closed dot. And because x is in between these 2 boundaries, we're going to shade in between. So -2. We have an open circle, and at 1, we have a closed circle. And then because it's in between our two boundaries, that's where we're going to shade. And the last one. To earn an A in a course, you must have a final average of at least a 90%. On the first 4 exams, you have grades of 86, 88, 92, and 84. If the final exam counts as 2 grades, what must you get on the final exam to earn an A in the course? So again, a lot of times that last sentence tells us what we want to have as our variable. So if the final exam counts as 2 grades, what must you get on the final to earn an A? So we're just going to let X be your grade on the final exam. So how do we figure out an average? Well, an average means that I add up everything I have and then I divide by the number of items that I have. So if I wanted to figure out the average of 90, 91, and 92, I would add 90, 91, plus 92, and then divide by 3 because I have 3 different numbers. The same thing happens here. So we want to find our average of our exams plus our final exam is included in this. We know that on the first exam, I have an 86. On the second, I have an 88. On the third, I have a 92. On the fourth, I have an 84. And then my final exam counts as 2 grades. So that's like having 2 additional tests, but they end up being the same score. So I'm going to add X and I'm going to add X because it's 2 additional grades. Now, how many tests am I counting here? I have 4 exams plus the 2 final grades, which is 6 things. And the goal is to have an average of a 90. So we want to set this equal to 90. Now that we have set this up, we want to go ahead and solve. So here, what is my LCD? My LCD is 6, and so we can multiply both sides by 6. So on the left, the 6's are going to cancel, and I'm getting rid of my denominator. So let's go ahead and add like terms on the top just to make our lives a little bit easier. So we have an 86, an 88, a 92, and an 84 we can add together. And that gives me 350. And then we have 2 x's, so plus 2x. And then on the right hand side we have 6 times 90, which is 540. And so now that we've done all this is pretty easy to solve. We want to get x by itself, so we're going to subtract 350 from both sides. And so on the left it cancels. We now have 2x is equal to 190. And then to undo our multiplication, we're going to divide by 2. And so we get x is equal to 95. So that's telling me to get a 90% average in the course, I would need to score a 95% on the final exam.